Okay, now it's often the case that in science measurements, we're often going to use either very large or very small numbers, and we just don't have the time to write a lot of zeros either way, big or small. So scientific notation is a really compact way that scientists use to write numbers, and it uses powers of 10. So for example, if I wanted to write the number 1,000, I know that that's the same thing as saying 10 times 10 times 10, which is the same thing as saying 1 times 10 to the third power, or 10 cubed, because we did it 3 times. On the same lines, if I wanted to take a tiny number like 0.001, 1/1000th, that would be the same as saying 1 over 10 times 1 over 10 times 1 over 10. Or I could write that with decimals, 0.1 times 0.1 times 0.1, which is the same thing as writing 1 times 10 to the minus 3. So you should be seeing now that large numbers have the 10 raised to a positive value for the exponent, whereas small numbers, like this one in this example, have the 10 raised to a power that is negative. So if I wanted to get us using 1, I could do another example like 5,000, which similar to our example for 1,000 would be 5 times 10 to the third. Or that's the same thing as saying 5 times 10 times 10 times 10. So 5 times 10 to the third would be scientific notation. Sometimes, rather than writing this whole part, we get even shorter notation, and we write it 5e to the 3, where this e here represents this times 10 to the third. So we're going to do some practice here where we're going to convert between decimal notation, decimal notation and scientific notation. So when we do these conversions, we're going to move the decimal point in our decimal notation either to the left or the right until there's only one number to the left of the decimal place. So we're going to move the decimal left or right until there's only one number to the left of the decimal. And every move that we make with that decimal point is going to be the equivalent of either multiplying or dividing by a power of 10. So let's take a couple of examples. So for example, the Earth is 4,600,000,000 years old. So if I were to write that out, 4,600,000,000. Had a little dog interruption there. So here's 4,600,000,000. So right now, the way I have it written, my decimal point is over here at the end. So I'm going to move it now, in this case to the left, until there's only one number to the left of the decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9. So at that point, if I wanted to write this number in scientific notation, it would be 4.6 times 10 to the 9th. So whenever you move the decimal point left, you get a positive value for the exponent right here. Okay? So let's do a tiny number now as another example. So the size of a red blood cell would be 0.000008 meters. That's very, very tiny. So I'm going to move my decimal point again. This time I've got to move it to the right. 1, 2, 3, 4, 5, 6. So I would write this number in scientific notation as 8 times 10 to the minus 6 meters, because I had to move that decimal point 6 places to the right. So whenever you move the decimal point to the right, that means you get a negative value for the exponent right up here. So let's do a couple of example problems. So I write some out here, and then you should pause and see if you can convert them to scientific notation, or from scientific notation back to decimal notation, and then check your answer. So here are the ones that I want you to try. So take these first two and convert them from decimal to scientific notation, and then take these second two and convert them from scientific notation back to decimal notation. So pause the video and give that a shot. So here's the answers. So hopefully you're noticing again that the larger numbers have the positive exponents, numbers greater than 1, whereas numbers smaller than 1 have the negative exponents. And then one of the real tricky parts sometimes that people forget is you really got to look for these small numbers and recognize that the more negative the exponent on that 10, the tinier the number. So that means that this number right here is a lot smaller than this number right here, which if you look at in decimal notation might be really easy to see, but sometimes it's easy to forget or to get mixed up when you're looking at the exponents. So remember, the larger, more negative exponent is the tinier number. And when all else fails, if you're not sure, convert it to decimal notation in order to see which number is bigger.